Okay, so here let's get into some deep solution architecture when you want to have data engineering pipeline that's going to be real time. So let's take an example. So we have producers and they can produce into a Kinesis data stream. So we think these producers can be the KPL, Kinesis agents and so on. Maybe once you analyze the data in real time, and so for this we can use Amazon Kinesis data analytics, and from this we can have Lambda attributes, some transformations. We can send the output data into Kinesis data streams as well, and we can also have Kinesis data firehose read from the output of the Kinesis data analytics, and this is what we just saw earlier. Okay, then in terms of analyzing the data, we have two options. We can use Amazon EC2 to read from our Kinesis data stream, and this is very helpful in case you want to have your own custom code to read from it. Or we can use Kinesis data firehose to send the data, for example, into Amazon S3 or Amazon Redshift, or to send the data into Amazon Elasticsearch service. So next, it is possible for us to also have a producer that produces data directly into Kinesis data firehose. So the KPL and the Kinesis agents have both have the capability to produce directly into Kinesis data firehose, and then the data will be sent to Amazon S3. So this gives us a bunch of different options, for our real-time layer. And as we can see, and also Kinesis data analytics here in this example can read from Kinesis data firehose. So I think I have represented all the possible combinations we can have when we have Kinesis. But the idea here is that you need to know which works with what, and what is the purpose of using Kinesis data streams, and Kinesis data firehose and Kinesis data analytics. So as well as your custom structure. Another architectural discussion we may have is we have different things to streaming in AWS. Okay, which one is going to be more cost effective? So let's say, for example, that you plan on receiving 3,000 messages of 1 kilobyte per second. So this is all data going to be sent to the your architecture. So option number one is to use Kinesis data streams with a Lambda function. So, and option number two is going to be using a DynamoDB table with DynamoDB streams and a Lambda function. So ask yourself which is going to be the most efficient, and what is going to be the most cost effective, and what trade-offs are we going to have between these two architectures, because they both work well. For Kinesis, I did some computations for you. So we have 3 shards because we need 3,000 messages of 1 kilobyte. So 3 sites is gonna be 3 megabyte per second, and the cost of 3 shard per hour is like 3 times 0.0015. So this is based on some numbers I found on the AWS website, and this gives you about $32 per month of cost. Then to send the data into Lambda, this is very easy. We can just use an event mapper, and if we wanted to send the data from long-term storage, we would need to use something like Kinesis data firehose, output it into S3, and you will get long-term storage there, because Kinesis data stream will have 24 hours to 7 days of data retention, but after that data will be lost. So this is a good combo to use Kinesis data firehose to persist the data into S3 very cheaply for long-term storage. And next we look at the DynamoDB streams. We need to have 3,000 writes of 1 kilobyte per second. So if you remember that 3,000 WCU write capacity units, and that gives you 3 megabyte per second. Now if you do a comparison of how much would that cost, this costs you about 1.4, about like 1,450 US dollar per month. So you should consider which one is more financially economical. So just for the DynamoDB table, so the good thing is that yes, we do get a storage in DynamoDB, so the data can be stored long term there, but the streaming aspect of thing is extremely expensive. So there's a factor 50 of cost between Kinesis like 50 times more higher. 50 cost like cost between Kinesis and the DynamoDB plus DynamoDB streams. So this is something you have to realize as a solution architect. It's not because something works, but it's going to be a great solution. And so in this example, both solutions work for streaming. But Kinesis is obviously going to be the much cheaper and probability better choice for what you are trying to achieve. Okay, so now let's look at the technology solutions so far for data exchange, and we can understand all the what are the different aspects based on data retention, ordering, scalability, and possible readers and latency. So Kinesis data streams is immutable data. So once it's inserted, we cannot change it, and the kind retention is between 1 to 7 days. We can export to S3 using Kinesis data firehose. The ordering is going to be per shard, and we have to provision those shards in advance. And the readers for those shards can be EC2 instances, Lambda function, Kinesis data firehose, Kinesis data analytics, and the KCL, Kinesis client library, that has a checkpointing feature. And in terms of latency, if we are using Kinesis data streams, then we have 200 millisecond latency, and if we are using Kinesis data firehose, it's not latency, it's near real time. It's near real time and latency. Near real time is going to have higher latency. That's so it's about going to be 1 minute minimum to be flushed at buffer size in that buffer into Amazon S3, for example. Next we have to let's look at the SQS. So SQS, the data is also immutable. Once it is inserted, it cannot be removed, and the data retention in SQS is going to be between 1 to 14 days. There is no ordering for SQS standard, and the scalability is virtually unlimited. There's soft limit, but you can always increase it. The readers of SQS is going to be EC2 or Lambda function. And the latency in this case is going to be quite low, between 10 to 100 millisecond. Then we have SQS FIFO, which is very familiar, very similar to SQS, but the data is still immutable. We still have the same retention period, but now there's an ordering we can have thanks to FIFO, which means they're the first in first out, so we get ordering per group ID. Now because we have this ordering constant, the scalability is going to be different. So we have about 300 around 300 messages per second, or 3000 if we are using batching by batching 10 messages at a time. The readers can also be EC2 and Lambda function, and the latency will be quite low, between 10 to 100 millisecond. Then we have SNS, which is also going to be immutable data. There's no data retention whatsoever, no ordering. This is going to be also something that scales very well, so there's a soft limit, but you can always increase it. And in terms of what can consume from SNS, these are called the subscribers. So you can be an HTTP subscriber, a Lambda function, an email, or SQS query. If we are using finite patterns, this kind of stuff, and the latency is going to be quite low, between 10 to 100 millisecond. DynamoDB now is going to be having mutable data. So once we insert data into DynamoDB, we can override it. The retention of the data can be infinite, or we can implement a time to live on our rows. There is no ordering in DynamoDB. For scalability, we have to use either some write capacity unit and read capacity unit to create and provision our database, and maybe have auto scaling on top of it. Or we can use on-demand scaling if we don't know our usage pattern and events, and if we have something very spiky, very unpredictable, or very abnormal. Finally, in terms of what can read from a DynamoDB, well, you have the SDK, but you cannot read a stream using the SDK. You need to create first a DynamoDB stream, and the DynamoDB stream can be read from a Lambda function or an EC2 instance, for example. The latency is also quite low, between 10 to 100 millisecond. And finally, S3. Yes, S3 is a way to stream Yes, S3 is a way to stream data if you wanted to. So if you are bit twisted, so you can insert data in S3 and replace it. So there is some mutable aspects, but we have seen that there is S3 object locks or versioning that can help against that. Okay, the retention is going to be infinite, and so we can set up lifecycle policies to transition between different tiers, and we can also have lifecycle policy to delete data. There's no ordering in S3, and for scalability we get about 3500 puts per second and 5500 gets per second per prefix, and the storage itself is infinite. And then the readers of the S3 can be the SDK. You get a specific object, or we can use S3 events to get notified whenever an object is inserted into S3. In terms of latency, it is also quite low, so about between 10 to 100 milliseconds. So that's it. And as of this comparison charts between all of the services kinds, data stream, SQS, SQS, FIFO, SNS, DynamoDB, and S3, it was helpful in understanding the architectural perspective, and hopefully it's very clear that what are the differences between all these technology, and you will be able to answer the questions based on them at the exam. And all right, that's it, and I will see you in the next lecture.